Here are the solutions to this week's problem set. This problem set reviews topics from chapters 7 and 8. Number 1. According to the Bureau of Labor Statistics, 72% of young women enroll in college directly after high school graduation. Suppose a random sample of 200 female high school graduates is selected, and the proportion who enroll in college is obtained. When we look at this set of questions, we can see that this is a CLT question because it's asking us about sample proportions and probabilities involving sample proportions, and also about the sampling distribution. All right, so what value would we expect for the sample proportion? Remember, the sample proportion should be similar to the population proportion. And since the population proportion is 72%, we would expect that the sample proportion would be very close to 72% as well. Describe the sampling distribution for samples of size 200 drawn from the population. Remember, this means to discuss the shape, center, and spread of the distribution. Okay, so we're going to make sure that we can apply the central limit theorem. So n times p, n is 200, so 200 times 0.72, and n times 1 minus p, in other words, 200 times 0.38. If you compute these values are both greater than 10. That means we can apply the CLT. So what does the CLT say? It says the sample proportions may vary from sample to sample, but their distribution is going to have a shape that's normal. It's going to be centered at the population proportion, which is 0.72. And we can compute the spread of the distribution, or in other words, the standard error, by using the formula square root of p times 1 minus p divided by n. So let's go ahead and calculate that. So if we take the square root of 0.72 times 0.38 divided by 200, we get a value of 0.037. So the sampling distribution is normal, its center is at 0.72, and its spread is 0.037. Use your answer to part B to complete this sentence. In a sample of 200 female college students, it would be surprising if less than blank percent enrolled in college. So remember, surprising means more than 2 standard errors from the mean. Sometimes we say that informally, that it's more than 2 hops from your mean. So if you take 2 hops from your mean, the question is, what would this number be? Well, it would be 0.72 minus 2 standard errors. And let's go ahead and figure out what that is. So 0.72 minus 2 times 0.037 is 0.646. Or in other words, 64.6%. So it would be surprising if less than 64.6% enrolled in college. Find the probability that in a sample of 200 drawn from this population, at most 65% enroll in college. So again, here's a picture of the distribution. And we're being asked to use this picture, to use this distribution, to find the probability that at most 65% enroll in college. So 0.65 would be located here, and the probability that we're interested in is the probability in this tail. And so to do that, we're going to use our normal calculator on StatCrunch. So you would go to StatCrunch, and we want a normal calculator, so we go to Stat, Calculator. Just 1 second while we try to do that. Try one more time. Stat, Calculator. We want a normal calculator. All right, the mean of the distribution is 0.72. The spread of the distribution is 0.037. And we're interested in the probability that at most 0.65 is the number of interest. So we'll compute. We check that this picture looks like the picture we were anticipating, and so that answer is 0.029. Or in other words, 2.9% chance. Okay, let's take a look at number 2. A political consultant is hired to determine if a school bond is likely to pass in a local election. In a random sample of 300 likely voters, 55% say they are in favor of the bond. Use the sample data to construct a 95% confidence interval for the proportion of all likely voters who are in favor of the bond. And so this is an example of a confidence interval problem. So to do a confidence interval problem, we're going to navigate to StatCrunch. The numbers that we need are x and n. So x is how many said yes. Well, 55% of 300 voters said yes. And so we're going to change this into a number. 0.55 times 300 gives us 165. And n, which is our sample size, is 300. And so we're going to use this data to find a 95% confidence interval. So we'll go to StatCrunch. And we'll come here to Stat, Proportions. We only have one group, and we have a summary. So make sure that you remember that this time we're doing a confidence interval, not a hypothesis test. So we'll make sure that confidence interval is marked. And here, the number of successes was 165 out of 300. And we have a 95% confidence interval in our box, and we'll compute. So our values are 0.494, 0.606. 0.494, 0.606. What that means is that in terms of the population proportion, we assume that the population proportion is going to be somewhere between 0.494 and 0.606. Okay, what is the margin of error for your confidence interval? Well, remember, this interval is built around the sample proportion of 0.55. And so your margin of error is the distance from your center to an endpoint. It's this distance right here. So to find that, you can just subtract. So we'll take 0.606 and we'll subtract 0.55 from that. And we have a margin of error of 0.056 or 5.6%. Based on your interval, should the consultant predict the bond will pass, why or why not? Well, remember, what does it mean to win an election? You get more than 50% of the vote. So I'm just putting 50% in the picture. Now, if you're, let me erase this because we don't need this anymore. All right, so if your total votes come out in this range, then you win. But if your total votes come out in this range, then you lose. Notice that our confidence interval includes values for which the bond passes and for which the bond fails. And so we cannot predict what's going to happen because our interval contains values both for winning and for losing. Problem 3 will be in the next video. On YouTube, I can only upload videos that are roughly 10 minutes. That's the maximum amount of time. And so that's why sometimes we get these solution videos in 2 parts.